Variation. Variation occurs in quite a few areas. One of them is a direct variation, and you'll realize that for a circle, as your radius gets bigger, so does your circumference. And so we would say your circumference varies directly to your radius. Whenever you're dealing with variation, you have a k for a constant of proportionality. In this particular case, your constant of proportionality is your 2 pi. Direct variation basically means as x increases, so does y. Or as x decreases, y decreases. All direct variation functions are a special linear function in which your y-intercept is 0. So all direct variation are written as y equals kx, where k is your constant of proportionality. Now, inverse variation, basically, as x increases, y decreases, or vice versa. All inverse variations can be written in the form of y is equal to k divided by x. Once again, k is your constant of proportionality. Here are the steps you're going to want to follow whenever you're solving variation problems. The fourth step, sometimes you'll have to do, sometimes you won't, depending upon what the problem is asking you for. Sometimes they're just asking you to find the value of k and write your general equation, which is up to step 3. Other times they'll be asking for more information and asking you to do step 4. Here we're told that w varies directly to z and inversely to the square root of u. You know, direct variation is always written in this form. So we're going to start off with w varying directly to z. So you know z has to be on the top. But now we're also told that it's inversely proportional to the square root of z. So the square root of z would need to be on the bottom. That is step 1. The next thing you want to do is you want to actually substitute in the given information so that you can find the value of k. In this case, they're telling you that your z here is 2, your u is 9, and your w is 6. So let's go ahead and plug that in. Square root of 9 is 3. So then you have 2/3 times k is equal to 6. So now we can go ahead and solve it for k. Multiply both sides by 3. And then now divide by 2 and we get k to be 9. All we're going to do at this point is to rewrite our general equation. We're going to replace the value of k with what k is of 9. When we actually do that, that completes the third step, which we call the particular equation. Now, there are times where your initial problem may actually ask you to find w given a new situation for z and u. In this particular case, they're not asking you to do that. Here you're told y varies directly to x and inversely to the sum of r and s. If it varies directly to x, you know x is going to be on the top. You need to also remember your constant of proportionality. Inversely, so you know that part's going to be on the bottom. Inversely to what? To the sum of r and s. Sum means what happens when you add. So this is your general equation. So now all we're going to do is plug in our values for x, r, s, and y so that we can go ahead and find the value of k. Now just go ahead and solve that. And we get k to be 8. Then once again, you want to go ahead and rewrite your general equation that you started out with the value of k in it. This is your particular equation, and that's all we were asked to find. We weren't asked to go ahead and find anything more, but in some problems you'll be asked to. The ideal gas law states that the volume of your gas varies directly to the proportion or directly to the product of the number of moles and temperature, and inversely to your pressure. Well, if it varies directly, you know you're going to have V equals K. You're always going to have a K whenever you're dealing with variation. Since it varies directly to the product, that's your answer after you multiply, to your moles and your temperature, you're going to have N times T on the top. On the bottom, it says inversely, so you got to have your pressure on the bottom. That's all we're looking for part A. Then we need to go ahead and say, okay, what happens if the number of moles is doubled, but the temperature and the pressure is reduced by a half? So you're going to replace your N with a 2N because it's being doubled. You're going to replace T with half a T and P with half a P because they're being halved. Now we want to see how does that compare to the original. Well, in this case, you have a half on the top, half on the bottom. They're going to go ahead and cross out. So what you're left with then is really just a 2 times the whole top and the bottom, which is really just double your initial amount. Since you're double what you had up here, you're going to say you're doubling your volume. And so then you're going to put that in your words, that your volume is doubled. So what would you do if it said it was reduced by a factor of a third? Well, if you take a third away, you're left with 2/3. So then you would replace your T with a 2/3 T. And then in this case, it would work down to be 2/3 of your initial. But however, what would you do if it was, say, 1/3 the pressure? If it was 1/3 the pressure, that means you're multiplying by 1/3. And so then you would put a 1/3 P in, and now instead of dividing by a fraction, you would multiply by the reciprocal. So you multiply by 3, and that ends up tripling your volume.